Now, we last saw the general sine function here. We're not going to do modelling, so we can skip this section. This isn't in the course, but we're doing equations involving sine. The first example is here, 4D1. The question says, use the graph of sine x to find the answer to this. When is sine x equal to 0.3? And we have a domain between 0 and 15. So on the graph above, we've got 0 here and 15 up here. And if we plot sine, you can see we've got 1 cycle, 2 cycles, 2 and almost a half cycles. Now, when is it 0.3? Well, 0.3 on the y-coordinate is here, 0.3. Whenever that's asking whenever the sine x value, which is the y value, is 0.3. Well, it's going to occur at that point there, that one there, 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 and there. So we're expecting 5 answers. Now, we can read off the x-axis what these values are, but we're not going to get an accurate answer. It'd be better if we went to the graphics calculator to try and get these corresponding x values. So we'll do that now. Here's sine x. So put in sine x, and we also want to put in a straight line, horizontal line of 0.3, so I can see where it intersects that graph. We're also going to change the window range, and the window, we want to go from 0 to 15, so I'll go 0 for the x min up to 15 for x max. The y coordinate goes from -1 to 1. We have to be in radian mode because you can see a full cycle is here, about 6.2. That's clearly 2 pi. If it was degrees, we'd expect that to be 360. So we'll just make sure in degree mode, click mode, and yes, it's locked on radian. So now we just have to press graph, and there's the sine curve from 0 to 15, and then now it's going to plot 0.3, and we're interested in the x values corresponding to the intersection points. Now, to find that, you just have to go second calc, intersect, which is 5, and you ask for the first curve, ask for the second curve, ask for a guess. So we're going to go over to the first point, and it'll give us the closest answer to that. So if we press enter, we get an answer of 0.304. So when x is 0.304, we have our y value as 0.3. So we can now add that in to the answer, and so I'll put the answer up here. So we have now sine x equals 0.3. This is 4D1, and we've got the constraint or the domain being 0 up to 15 for x. The first value we have is x equals 0.305. 0.305. And we get another value which is the next one over here. So we're just going to go second calc intersect and click the first curve, press enter, second curve, enter, ask for another guess. This time we're going to head a little bit closer to that second point over here and press enter. So now it's 2.84 is the next one. So x is 2.84. Now we've got other values too. We could actually keep adding 2 pi onto this, a multiple of 2 pi, and we tend to say k 2 pi. That's where k is 1, 2, 3, etc. integers, and we can add on k 2 pi to this answer. I'll show you what I mean by that. In here we can see that this point here is one answer. Now the next answer, if we add on 2 pi, is this one here. That is a full cycle apart. So if we add on 2 pi to that x, we get that. If we add another 2 pi, we'll get that. Likewise, the second one we wrote down is this one. If we add on 2 pi to that one, we get that one. If we add on 2 pi to that, we're outside the region. So we just want 2 of those. So we've got to get 3 of the first, 2 of the second. Okay, so back onto solutions. We can now keep going and saying that that is 0.305 comma, and the next one is 0.305 plus 2 pi. So to get that value, we're going to do 0.305 plus 2 pi, and so that is 6.59. So we can add in 6.59, and the next one, if we just add 2 pi to this one, then the next one is 12.87. Now we can't add any more because we'll be outside 15. Then we go to the other one, which is 2.84. 2.84, and we add on 2 pi, and we get 9.12. And then we add on another 2 pi, and you can see we're past 15, so we can't include that point. So that is our complete answer there. We've got 5 values corresponding to the x values that will give a sine value of 0.3 or a y coordinate of 0.3. Now that is looking at it from the perspective of a wave. So we're looking at that 1 cycle, 2 cycles, and then it was another one, a little bit of a half there. That was the sine x from 0 to 15, and we found all of these points here. Now the other way of thinking of it is not as a wave, but as a unit circle. It's exactly the same as thinking of it as the y coordinate is 0.3. Now the y coordinate being 0.3, we know this is 1 and this is a half, so 0.3 is around about here. Now the point corresponding to that is this one over here and this one over here. That there is an x value, comma, 0.3, and this here is minus x value, comma, 0.3. And we're trying to find out the angle that that corresponds to. So here is the angle, and we found out the first one is 0.305. So that angle in there is 0.305. The other one is over here, and that's 2.84. But from there all the way around to there is 2.84. Now you can see when you add on 2 pi, if we take the first one, which is 0.305, and you go around the circle with a full rotation, go right around, then you'll get the next one, which is 6.59. If you go around again, you'll get the next one, 12.87. Likewise down here, this value here is 2.84 sitting on the left hand side. If we do a complete rotation, then we'll get to 9.12. So you can think of it in terms of the waves. You've got the periodic nature of the waves repeating itself, or as a circle, which is also periodic in nature, repeating itself as you go around. Okay, so that was answering that question. We needed to find the x values corresponding to that solves that equation. And now you can have a go at B, so just pause the video and come back and see the solutions to B. And here are the solutions. There's 1A, 1, 2, 3, 4, 5, and B, there's only 3 answers, 1, 2, 3 there. Okay, now we're going to, instead of use the graphics calculator, we're going to do it algebraically, exactly the same way. So we'll do the first one, 4D3, and we'll start with question 2. Okay, so the question is solve this equation, 2 sine x equals 1, and this is our domain from 0 up to 6 pi. First thing we need to do is take 2 over the other side, so sine x equals 1 divided 2, sine x equals a half. Now we can think in terms of the unit circle, and when the y coordinate is a half, we need to know what the angles are. So that point and that point, those two angles we need to know, and because the domain's in radians, we need the angles in radians. Now for a half, if you look up your unit circle, you'll find that this point here is root 3 on 2 comma a half, and this one is minus root 3 on 2 comma a half. But the angle in here is 30 degrees, or pi on 6, and the other angle is from here all the way around to the other side, that is 5 pi on 6. Okay, so we can come back here and now say that x equals, the first one is pi on 6 and the other one is 5 pi on 6, but we can add on k to pi, a multiple of 2 pi, to both of these as we can go around the circle. So now we can work out our final answer without using a calculator. Now pi on 6, if you add on 2 pi, I'll do the working over here, pi on 6 plus, now 2 pi, I'm going to call 12 pi on 6, so that I'll have the same common denominator, because that really is 2 pi, and so that's going to give us 13 pi on 6. So the answer is pi on 6, comma, 13 pi on 6, comma, we add on another 2 pi to this, so add on another 12 pi on 6. If you add on 12 to the last answer, you will get 25 pi on 6. So that's our next one. And we're so far up to roughly about 4 pi. If we add on another one, 12 pi on 6, then we'll get up to 37 pi on 6, and that's past 6 pi, because 6 6 is 36, we're past 6 pi. So we stop there. Now we come down and do 5 pi on 6. Once again, we're going to sequentially add on we're going to add on the 2 pi's, So starting with 5 pi on 6, if you add on 12 pi on 6, then we'll get 17 pi on 6. That's the next one. And if you add on another 2 pi, then we'll be up to 29 pi on 6. And that's the end, because if we add on another 12 pi on 6, will be outside the 6 pi region. So we have 6 answers there for x values in that region that will give a sine value of 1/2. We'll basically just solve that equation there. Okay, now you can try the others, but I'll just show another type when you get down to something with a 2 in the x. It crops up here in G. So we'll just do G and then you can have a go at the others. Look at G. We're going to have sine 2x equals 1/2, and we're between 0 and 3 pi. Okay, now what we have to do, sine 2x, notice the 2 is wrapped up with the angle, so first of all we can do shift sine, or just without the calculator, just use the unit circle. It's the same as the last one. We know that the angle corresponding to a y coordinate of 1/2 is pi on 6 and 5 pi on 6. Now the difference is that that means 2x. When we're working out the angle here, that's 2x. That is going to be either pi on 6 or 5 pi on 6 plus our k2 pi. But this time we have the 2x being equal to that, whereas before it was x being equal to that, because 2x is the angle. So we want to get x, so the next thing to do is divide both sides by 2. So if we divide that by 2, instead of pi on 6, it's going to be pi on 12. If you divide that by 2, the bottom gets bigger, and this one will be 5 pi on 12. But we also have to divide the k2 pi by 2, so that's going to become plus k pi, and this is plus k pi. Okay, and so now we actually go through the same process. It's pi on 12, comma, we add on pi. Now adding on pi is like adding on 12 pi on 12. We add on 12 pi on 12, we'll get 13 pi on 12. We add on another 12 pi on 12, we'll get 25 pi on 12. And if we add on another one, we will go beyond the 3 pi, so we stop there. And down the bottom we have 5 pi on 12. Once again, add on 12 pi on 12, and we'll have 17 pi on 12. And if you add on another 12 pi, will be 29 pi on 12, and stop there. So we get 6 answers solving that equation. Okay, now you try the others, and you can pause it and then come back for the solutions. And here are the solutions for 4D3, question 2, A through to K.